We are going to be starting our second unit today, and instead of doing equations, which is what we looked at for the first part of the school year so far, we are going to be looking at inequalities. And we're doing three things with inequalities today. We're solving them, writing them, and graphing them. So there's kind of a lot going on. You can kind of get an idea what the problems look like. Before we get there, though, we need to talk about what an inequality is. So an inequality is we'll say a math phrase that uses an inequality sign instead of an equal sign. Okay, so make sure you're taking good notes with me. You're writing everything in as I am. We'll cover everything you need to know here. So you guys hopefully remember inequality symbols from pre-algebra and back in middle school. So there's 4 of them, and I'm going to jot them all down here. You've got these two. This first one is less than. So no longer are things equal. I'm not going to have something like 2x equals 8. It's not going to happen. I'm going to have something like 2x is less than 8. Okay, so they're just going to take the equal sign out and put in something that's not equal, or a less than, a greater than, whatever. Okay, so that first one's less than. This second one is greater than. To keep these like separate from each other, a lot of people think the less than's like this. If you turn it like that, it's kind of like an L. So that's your less than. And then you have the two less than and greater than signs with the little or equal to line underneath. So this one is less than or equal to. And this one is greater than or equal to. So hopefully you kind of are familiar with those 4 symbols already. Basically the biggest difference is when you're solving something, an inequality, a less than, just adds so many more solutions than an equation ever would have had. But we're still going to be solving things just like we did last unit. Okay, so the directions say solve each inequality, get x by itself, and then graph your solution on a number line. So I cannot forget to do that part. Okay, so on number 1, I just need to get x by itself. And you can still draw the line through the sign to show you what's on the left and what's on the right. But I'm going to undo stuff just like I'm used to. So if I move the 4 over, then I have x alone. So I'm just going to subtract it to undo it. And then I'm looking at x is less than 3. Now, before you guys, we did equations and we got answers like x equals 3. An answer like this, there's one solution, 3. That's it. But for an inequality, x is less than 3, all of the numbers that are smaller than 3 work in this inequality. So I could plug in 2, 1, negative 5,000. Any number smaller than 3, I can plug it in here, and it makes this true. So our answer options have just increased by so many now that we made it a different symbol. You have to graph your solution. So you have to show me where are all the possible answers. Okay, so they'll probably give you like a little number line here. I always put 0 in there and then just the number that I'm looking at. So you don't have to go in and put -1, -2. You don't have to fill in tons of different numbers as long as you get like where 0 is and the number you're looking at. I have to show someone that all of the numbers smaller than 3 make this true. So here's what I'm going to do. Above the 3, because that's the number we were looking at, you either put an open circle or a closed circle. And you need to think, is 3 a solution? So let's see, if I put 3 in here, 3 is not smaller than 3. So 3 doesn't work, so you don't want to color over 3. You put like an open circle. I want all the numbers smaller than 3, which are to the left. So I'm going to shade to the left here. And this is my graph. Doesn't include 3, it's an open circle, but all the numbers smaller than 3 make that work. So this is you showing someone where the answers are. Okay, let's do the next one. You need to solve for n, so I'm going to start by adding 7. And I get n, bring my sign down, and that's 5. Okay, as soon as I have n by itself, I'm done, but now I need to graph it. Now, this time, if I plug in 5, if I think about numbers that work, this time 5 is less than or equal to 5. So that or equal to makes this work. So 5 is a solution. So I want to put a closed circle above 5. Okay, so I want you to come up here before we shade and make a note. On the graph, you guys, and this happens every time, if it does not have that little or equal to symbol underneath, these are open circles on the graph. These two. If it does have that little or equal to, then it's going to be a closed circle on the graph. Okay, we'll kind of separate them. These two have an open circle. These two have a closed circle. Okay, so make sure you know the difference there. That's going to affect when you graph your solutions on the number line. Now, here's what we want to do for the shading part. I need to figure out what numbers can I put right here are going to make this true. So the mouth open towards the bigger one, so 5. Numbers that are smaller than 5 make this work. So 4, 3, 2, 1, negative 30, whatever. Numbers smaller than 5. Now you want to show that down here. So numbers smaller than 5 are to the left. So I want to shade to the left. Here's the mistake people make. They always follow the sign like an arrow, which it worked here. Ooh, arrow pointing left, shade left. They'll see this as an arrow pointing right, and they'll shade right. The arrow trick only works if the variable is on the left-hand side. Okay, so check it out. The variable is on the left, so I can follow this like an arrow. Over here, the variable is on the right, and that is when the arrow thing does not work. So I'm going to make a little note here. Arrow trick only works when the variable is on the left. And I'm going to highlight that because that is really important. People will shade the wrong way on the number line because they always follow it like an arrow, but it only works when the variable sits on the left-hand side. So be careful. For the next one, this one takes 2 steps to solve for x. So you got to subtract 4. And then you got to times by 2. Realize that none of that is different from what you're used to with equations. You got to show the solutions. Okay, it is a greater than with no little or equal to underneath, so it's an open circle. The variable is on the left, so I can follow that like an arrow and shade right. All the numbers bigger than negative 14. Okay, the next one. To get w by itself, I need to divide by negative 2. Okay, the only thing that you guys have to remember really is a problem like this. If you multiply or divide both sides by a negative number, you have to flip the sign. So it was a less than or equal to. I'm going to flip the mouth around and make it a greater than or equal to. You absolutely have to make this note. Flip the sign. When you multiply or divide both sides by a negative. Honestly, remembering when to flip the sign, that is the only thing that's different between equations and inequalities. So in the back of your mind the whole time, and I'm going to highlight this too, you just gotta look out for dividing or multiplying both sides by a negative. If I multiply both sides by a negative 2 like I did here, I had to flip the sign, because that changes where all the solutions are. I'm going to graph it like normal though. So this one's a closed circle. And okay, the variable is not on the left, so I can't use the arrow trick. I need numbers smaller than -5. It's not going to go right like the arrow looks. I got to go the opposite way. So that's my graph. Okay, next one. I'm going to add 10. And now that we know this little flip the sign trick, I got to look out for it. Divide by 2. And it is less than -6. Okay, I do not have to flip the sign. People will think, oh, -12 divided by 2. Yeah, I need to flip the sign because that was a negative number right there. But it's what you do to both sides. So in pink pen is what I did to both sides. We divided by +2, not negative, so do not flip it. This one's good. I'm going to do an open circle. M's on the left, so I'm going to follow that like an arrow. Shade left. Last one. I've been doing this all year so far. I don't like the fraction, so I'm going to put the n on top. I'm also going to put the negative on top and make the left side look like that. Maybe that helps you a little bit, kind of see what to do first. I'm going to take care of the 3, and I'm going to multiply by 3 on both sides. I get -2n is less than or equal to 6. Oop, wrong color. And then I'm going to divide by -2. Okay, a little red flag should go off in your mind. We divided both sides by -2, so I have to flip the sign. Be careful. It's a greater than or equal to now. This one's going to be, move it up here for you, a closed circle. Variable's on the left, so I'm going to shade right. Okay. Solving and graphing, that's that for the first part there, 1 through 6. But you also have to be able to write an inequality from a situation. So they're saying define a variable and then write the inequality. The situation is you must be at least 18 years old to vote. Okay. I need to put something on each side of the sign. The number obviously sits on one side. Okay, you need to think for your variable. I need to be at least 18 years old. So what has to be at least 18? Your age. That's what we're talking about, A for age. So that goes on the other side. It's the sign that throws people off. So my age right here, I need to be at least 18. So I got to be 19, 20, older than 18 to be able to vote. So the mouth needs to open towards 18. And I'm going to add a little or equal to, because if I'm exactly 18, then I can vote. So that's what I want to write.